Hello everyone, and welcome back to the RE07 channel. I'm Peter Ree, and today we are stepping into real-world hydraulic system engineering. In this lesson, we will learn how to design a hydraulic lifting system capable of lifting a 3,000-kilogram load, and more importantly, how to build a Python calculator that automatically sizes the hydraulic cylinder, pump, and motor. This is not just theory. These calculations are the same steps used by professional hydraulic engineers when designing industrial lifting machines, elevators, presses, and heavy load platforms. So if you are a mechanical engineer, automation student, or anyone interested in hydraulic design, this lesson is for you. Let's begin. Understanding the design objective. Before writing any code, we must understand what we are designing. Our goal is to create a hydraulic lifting system that can raise a heavy load vertically. In our example project, the load is 3,000 kilograms, but in hydraulic design, knowing the load alone is not enough. We must also define how high the load must be lifted, how fast it should move, what pressure we will use, and how safe we want the system to be. Once we know these inputs, we can calculate the required cylinder size, pump flow rate, and motor power. This is exactly what our Python program will do automatically. Now, in our calculator, we ask the user to enter 5 important values. First, the load in kilograms. This tells us how much weight the system must lift. Second, the stroke length in millimeters. This is how far the cylinder must extend to raise the load to the required height. Third, the lifting speed in millimeters per second. This defines how fast the platform or load should move upward. Fourth, the working pressure in bar. This is the hydraulic pressure available from our pump and system. And finally, the safety factor. In engineering, we never design exactly at theoretical limits. A safety factor ensures the system can handle unexpected overloads, friction losses, and wear over time. For industrial lifting systems, a safety factor of 1.5 is a common and realistic choice. These 5 values form the input section of our Python program. Converting load to force. Hydraulic systems work with force, not mass. So the first calculation in our program converts the load in kilograms into force in newtons. We use the equation force equals mass times gravity times safety factor. Gravity is 9.81 meters per second squared. So, for a 3,000 kilogram load and a safety factor of 1.5, force equals 3,000 times 9.81 times 1.5. This gives us approximately 44,000 newtons of required lifting force. This is the force that our hydraulic cylinder must generate to safely lift the load.
Cylinder area calculation. Once we know the required force, we can calculate the necessary piston area. Hydraulic pressure and force are related by Pascal's law. Pressure equals force divided by area. Rearranging the formula. Area equals force divided by pressure. In our program, we convert the working pressure from bar into pascals because standard physics equations use SI units. 1 bar equals 100,000 pascals. So if the working pressure is 160 bar, that becomes 16 million pascals. Then the program divides the required force by the pressure to obtain the piston area in square meters. Cylinder bore diameter. Once we have the piston area, we calculate the cylinder bore diameter. The formula for the area of a circle is area equals pi times d squared divided by 4. Rearranging for diameter. D equals square root of 4 times area divided by pi. The program performs this calculation and converts the result into millimeters. However, in real life, cylinders come in standard sizes, such as 50 millimeters, 63 millimeters, 80 millimeters, and so on. So our program also compares the calculated bore size with a list of standard cylinder bores and selects the closest standard value. This makes the output practical for real equipment selection.
Pump flow rate calculation. Next, we determine how much oil the pump must deliver. Flow rate depends on a piston area, a lifting speed. The formula is flow equals area times velocity. The program multiplies the piston area by the lifting speed to obtain flow in cubic meters per second, then converts it into liters per minute. This gives us the required pump capacity. To ensure stable operation, we add a small margin and recommend a slightly larger pump size.
7. Motor power calculation. Now that we know pressure and flow rate, we can calculate motor power. A common hydraulic engineering approximation is motor power, kW, equals pressure in bar times flow in L per minute, divided by 600. This formula accounts for typical system efficiency and gives a realistic motor power requirement. Again, the program adds a small margin and recommends a practical motor size available on the market.
After performing all calculations, the program prints a clean and professional result summary: required lifting force, calculated bore diameter, recommended standard cylinder size, pump flow rate, recommended pump capacity, motor power, recommended motor rating. At the end, the program displays a friendly message thanking the viewer. Why use Python for hydraulic design? You might ask, why build a calculator instead of doing manual calculations? In real engineering projects, designs change constantly. A client may change load weight, lifting speed, available pressure, required stroke. With a Python calculator, we simply enter new values and the design updates instantly. This saves time, avoids calculation errors, and allows fast feasibility studies. This is exactly why automation and programming skills are now essential for modern mechanical engineers.
10. Real-world application. The results from this program can be directly used to select hydraulic cylinders from supplier catalogs, choose pump and motor sizes, estimate system power consumption, prepare preliminary project quotations, design hydraulic schematics. Of course, a final industrial design always includes additional checks, such as mechanical frame design, buckling analysis, oil cooling, and safety certifications, but this calculator provides an excellent professional starting point. Engineering best practices. When designing real hydraulic lifting systems, always remember, never exceed rated component pressures. Always include a pressure relief valve. Lesson summary. Today, we learned how to define hydraulic design input parameters, convert load into lifting force, calculate cylinder bore size, determine pump flow rate, estimate motor power, automate the entire design using Python. This combination of mechanical engineering knowledge and programming automation is exactly what modern industrial engineers need.
And that brings us to the end of today's lesson. If you found this tutorial helpful, please give the video a like. Don't forget to subscribe to the RE07 channel for more mechanical engineering and Python automation lessons. Feel free to leave your questions or project ideas in the comments below. Thank you for watching. See you in the next lesson.